Okay, I think, yeah, I'm in live. So, okay. So, did you guys do my homework?
Yes.
Any problem in solving the system of linear equations? No? No problem? Can you do that? Okay, great. Then, I think I don't have to check, but remember that that's very important. And practice, and practice, and practice. Okay? So, in case of OLS matrix, we also assume some kind of data generating process. In this case, y equals xb plus e, something like this. Okay? In the mathematical example, y1, y2, y3, for example, when we have only 3 observations, that is Y matrix. Okay? In this case, 3 by 1 matrix. X matrix is defined as 1, 1, 1, x1, x2, and x3. This is X matrix. This is 3 by 2 matrix. And there's B matrix. This is alpha and beta. And 2 by 1 matrix. And plus error term, epsilon 1, epsilon 2, and epsilon 3. This way. Okay? This is 3 by 1 matrix. Then this is the same as something like 3 by 2 and 2 by 1. Okay? Then this one is alpha plus beta x1. Okay? Alpha plus beta x2 plus epsilon 2. Something like that. Okay? So y1 equals alpha plus beta x1 plus epsilon 1. y2 equals alpha times beta x2 plus epsilon 2. We write this kind of thing in this matrix version. Okay? So this is OLS matrix version, and we have some kind of assumptions. Okay? The first assumption is expected value of this error term equals 0. This is the first assumption. If you remember when we do some kind of this kind of thing, yi equals alpha plus beta xi plus epsilon I, we had some assumption on this epsilon I. Epsilon I is distributed by normal, mean 0, variance of sigma square kind of things. Okay? So when you remember, or when you try to remember, we have 3 data points. We are trying to find some kind of feeding line. Okay? The feeding line, if the feeding line is something like this, we think this distance, and this distance as an error. This one is epsilon 1, this is epsilon 2, this is epsilon 3, something like that. Then the mean, the average of this one is on 0. Okay? Later we relax this kind of assumption, also this kind of assumption, but in the strongest assumption, we assume that this epsilon I is 0. The mean of it. Okay? This one similar here. So in this case, we can write it down in a different way. Epsilon 1, epsilon 2, epsilon 3. This is E vector. Okay? And the mean of epsilon 1, error term 1 equals 0. The mean of epsilon 2 equals 0. The mean of epsilon 3 equals 0. Okay? In this case, this one is related to IID assumption. IID means independently and identically distributed. This kind of independence means that former outcome, the past outcome, do not impact future outcome. That is the meaning of independence. If you flip a coin, when you get head, the probability of getting head in next trial is still half. The past outcome do not impact the future outcome. That is independent assumption. Identical assumption is that when you flip coin number 1, coin number 2, coin number 3, coin number 4, all of them are identical in terms of getting head. Okay? When you have 4 different coins, coin number 1, the probability of getting head is half. Coin number 2, it's the different coin, but distribution is identical. The probability of getting head is still half. Coin number 3, the same. Okay? So here, this kind of assumption, the expected value of epsilon 1 is 0. Expected value of epsilon 2 equals 0. Expected value of epsilon 3 equals 0. That is more likely identical distribution assumption. Okay? All 3 of them, they are the same random variable. They are identically distributed. Okay? They are all different random variables, but their distribution is the same. This is coin number 1, this is coin number 2, this is coin number 3. As a random variable, they are different coins, but probability of getting head is still the same. In this case, we think epsilon 1 is normal distribution, mean 0 has variance of sigma square reflected. Okay? Epsilon 2, the distribution is identical. Mean 0, variance of sigma square. Okay? That kind of assumption is this assumption. The second one is variance of E. In OLS, almost everything is about variance and variance and variance. Okay? So how do we calculate variance of E? That is expected value of E and E transpose. So do you guys remember what is the transpose? Okay? So let me teach you what is transpose. Here, X matrix 1, 1, 1, x1, x2, and x3. This is X matrix. X transpose matrix, any idea? That is 1, 1, 1, x1, x2, x3. Okay? This is the transpose matrix. Transpose means that change column into row. Change column into row. Okay? This is 3 by 2 matrix. This is 2 by 3 matrix. Okay? So this is the meaning of transpose. Change the column into row. Okay? This transpose is very, very important. So in this case, what we calculate is E and E transpose. Okay? Then we are trying to calculate expected value of E, what is E? Epsilon 1, epsilon 2, epsilon 3. What is E transpose? Epsilon 1, epsilon 2, epsilon. Okay? This is 3 by 1 matrix. This is 1 by 3 matrix. 3 rows, 1 column, 1 row, 3 columns. Okay? Then this one and this one, they match. Okay? Then the result is 3 by 3 matrix. Then the expected value of what? This one, first row, first column, epsilon 1 square. Okay? Epsilon 1 times epsilon 2 here. Epsilon 1 times epsilon 3 this way. Okay? The second one is epsilon 2 times epsilon 1, epsilon 2 square, epsilon 2 times epsilon 3. Epsilon 3 times epsilon 1, epsilon 3 times epsilon 2, epsilon 3 square. Okay? This one. Question? Then, when we assume this kind of IID type assumption, okay? What is the variance of epsilon 1?
0.
No, that is the mean. Oh, I just deleted it. Epsilon 1, I, distributed by normal, mean 0, variance of sigma.
Square.
This is mean. The variance is sigma squared. Okay? What is variance? Expected value of epsilon I equals 0. This is mean or average. Okay? What is the variance of epsilon I? This one is expected value of epsilon I minus expected value of epsilon I square. Do you remember this concept of variance? Mean deviation. This is mean deviation. Square it, calculate the average. The variance was average of squared mean deviations. Okay? I emphasized it over and over in my last class. Variance, average of squared mean deviations. Okay? Remember? When you have 1 and 3, average is 2. Okay? This is average. What is variance? 1 minus 2. This is mean deviation. Okay? This is average or mean. The difference between 1 and 2, that is mean deviation. You square it. 3 minus 2, this is another mean deviation. Square it. Calculate average of it. That is concept of variance. Okay? Question? If you have question, check about variance, check your last semester's note. Remember something about variance? Variance is the average of squared mean deviations. This is mean deviation. Square it, sum it, calculate the average. That becomes variance. Okay? In this case, this is the variance. Let me delete this part at this moment. Okay? this is the data point. The data point like this. Okay? This is average. This is average. Subtracted. Mean deviation. Square it. Calculate the average of it. Okay? So this is the concept of variance. Average of squared mean deviations. Then this one is the same as, because expected value of epsilon I equals 0. Okay? Expected value of epsilon 1 minus 0, epsilon I square, something like this. Okay? This is mean 0, subtract 0, that is nothing. Then that is the same as expected value of epsilon I square. Okay? This is variance. In case of error term, average of epsilon I square, that is variance. Okay? Then from our assumption, what is this one? Variance is, from our assumption, we assumed it is sigma square. Okay? This is our assumption. We assume that average of error term equals 0. We also assume that average of error term, variance of error term, that is the same as expected average of epsilon I square, sigma square. This is our assumption. We assume this. Okay? Question? If this one means that this is our assumption, that means expected value of epsilon 1 square. This is variance of epsilon 1 square. What is this one? Sigma square. Okay? Expected value of epsilon 2 square. This is epsilon 2. What is the variance this one? Sigma square. Expected value of epsilon 3 square, sigma. Okay? We have 3 different random variables. 3 different coins. Okay? All of them are different coins, but anyway, they have the same distribution. Probability of getting head, coin number 1, coin number 2, coin number 3, the same. Distribution is identical. Okay? When we say distribution is identical, we mean is the same, variance is the same, and something called kurtosis is the same, but forget about that concept. Okay? When we say mean and variance is the same, we usually think distribution is identical. Okay? So in this case, we assume identical distribution. Random variable number 1, random variable number 2, random variable number 3, all of them, their average equals mean equals 0. Okay? Then the variance is this one. You eventually get this one. Okay? Then what is expected value of epsilon 1 square? That is sigma square. Distribution is identical. Coin number 1, coin number 2, coin number 3, different coins, but anyway, they have the same distribution. Expected value of epsilon 2 square, that is sigma square. Okay? Expected value of epsilon 3 square, that is sigma square. Okay? This is one assumption. Another assumption is this kind of independence assumption. This part, this part is expected value of epsilon 1 times epsilon 2. Okay? I'm talking about this part. Okay? Expected value of epsilon 1 and epsilon 2. Okay? When they are independent, only when they are independent, this one is the same as expected value of epsilon 1 times expected value of epsilon. Okay? That's why we assume independence. Then, expected value of epsilon 1, what's that? 0. Times
0.
Okay? So we generally call this term as covariance term. Okay? This part is the same as expected value of epsilon 1 minus expected value of epsilon 1 times expected value of epsilon 2 minus expected value of epsilon 2. What is this one? Expected value of epsilon 1 minus 0. Expected value of epsilon 2 minus 0. We can simply forget about this one. Okay? Then this one becomes expected value of epsilon 1, epsilon 2. Okay? This is what we see. It's the same as this one. This is the same as this one. If you study the definition of covariance, this is the definition of covariance. Okay? Variable number 1, variable number 2, their mean deviations. Okay? We multiply them, calculate its average. Okay? Mean deviation of variable number 1, mean deviation of variable number 2, multiply them, calculate the average, that is covariance. I will teach this one later more seriously, but if you have time, look up the definition of covariance. Okay? So, this is variance term, this is covariance term.
So how do you write covariance?
COV. COV epsilon 1, epsilon 2. Good question. This is definition. Okay? So we generally call it this one as variance covariance matrix. All the variance is sigma square, sigma square, sigma square. This kind of cross product term, covariance, when they are independent, 0. So 0, 0, 0, 0, 0, 0. Okay? Then this one, let me write down here. This one can be written as sigma square times 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? Sigma square times 1, that is sigma square. Sigma times square times 1, sigma square, we can write down in this way. Question? Then, what is this one? You just wrote it in my last class. This is identity matrix. Okay? So this is the same as sigma square identity matrix. When the diagonal is 1, all the other part is 0, we call it identity matrix. In case of 2 by 2, what you see is this one. This is identity matrix. 3 by 3, this way. Okay? Diagonal matrix is 1, off diagonal ones, 0. Okay? So for some people, they write it down. Variance of E, for simplicity, sigma square I. Simple. Okay? But anyway, what you need to remember is variance of E is indeed variance covariance matrix. Okay? The most important part, or some people do not pay attention, is this one is E times E transpose. Okay? When you calculate E transpose E, this is totally different. Okay? Then this one is 1 by 3, 3 by 1 matrix. What you will get is 1 by 1. Okay? This 1 by 1 value is totally different from this E transpose. This is 3 by 3 matrix. This is 1 by 1 matrix. So please pay attention. When you calculate variance covariance matrix, this one, E transpose. Okay? If you do not pay attention to this one, your life will get very complicated. E transpose, variance covariance matrix, diagonal ones are sigma square, off diagonal ones are 0. Okay? This is the property of variance covariance matrix of OLS. Okay? Then we also assume, should I delete this part? No, why don't we delete this entire part? Another assumption number 2 is something like this. X transpose E expected value equals 0. For simplicity, I called it assumption. When you run something higher, in the higher level, you use different assumption. But this is for simplicity, and at your level, this is just fine. Okay? This kind of thing in general means that this kind of X and E, they are not correlated. That's the meaning of this one. X and E. So what is this one? What is our X matrix? Our X matrix is 1, 1, 1, X1, X2, and X3. Okay? What is X transpose in the case? 1, 1, 1, X1, X2, X3. Okay? This is X transpose part. This is epsilon 1, epsilon 2, epsilon 3 part. Okay? Then, what do we get? Epsilon 1 plus epsilon 2 plus epsilon 3. This one. Okay? And x1 times epsilon 1 plus x2 times epsilon 2 plus x3 times epsilon 3. Okay? This one times this one, this one times this one, this one times this one. Okay? What is this one? This is the same as summation I equal 1 to 3 epsilon I. Summation I equal 1 to 3 xi epsilon I. That's it. Okay? It means that this one equals 0 and 0. This way. Question? Then let's go back to our OLS in terms of mathematics. Okay? What I said a lot in my last class was, in case if I am not using matrix, y equals alpha plus beta xi plus epsilon I. Okay? Epsilon I is distributed by normal mean 0 sigma square is something like what I said. Okay? Then what is OLS? The purpose of OLS is minimizing sum of squared residuals. Okay? I said it over and over and over. Minimizing sum of squared residuals. How did you do that? yi minus alpha minus beta xi. This is the residual. You square it. You sum it. Minimize it with respect to alpha and beta. Okay? This was the purpose of OLS. How do you do this? Summation I equal 1 to n yi minus alpha minus beta xi square. Let's take derivative with respect to alpha. Okay? Chain rule, all the other things, partial derivative and those kind of things. If you don't remember it, go back to your home, study it again. This is a required part. That's why I emphasized it over and over and over in my last semester. Okay? What is the result? Summation I equal 1 to n 2 times yi minus alpha minus beta xi times negative 1. Okay? Here is negative alpha. Take partial derivative with respect to alpha. 2 times entire thing. Partial derivative with respect to alpha, negative 1 is here. This one equals 0. Okay? This is something about partial derivative and chain rule and those kind of things. If you forgot this part, memorize it, go back to your home, study it again. Okay? Then what you have is here is 2 and negative 1. You divide both sides by negative 2. What you get is summation I equal 1 to n yi minus alpha minus beta xi equals this way. Okay? I called it this one as the first normal equation. Okay? Then what is this one? This one is the same as epsilon I. Okay? Here. Epsilon I is yi minus alpha minus beta xi. Okay? This is epsilon I. Then this one is the same as summation I equal 1 to n epsilon I equals 0. What is this one? Here. Okay? So that's what this one means. You have something to be surprised one more time. This one is also here. When you take partial derivative, summation I equal 1 to n yi minus alpha minus beta xi square. Let's take partial derivative with respect to beta. Okay? Summation I equal 1 to n 2 times yi minus alpha minus beta xi. This is the first part of chain rule times we are taking partial derivative with respect to beta. This is negative beta xi. What remains is negative xi equals, here is 2, here is negative 1. If I divide both sides by negative 1, what you will get is summation I equal 1 to n yi minus alpha minus beta xi times xi equals 0. What is this one? Epsilon I times xi summation I equal 1 to n equals, that is the same as this one. Okay? The location is changed, but
The same.
they are the same. So this one is normal equation number 1. This is normal equation number 2. We assumed it here in this way, but indeed this is the derived result of the OLS. That's why OLS is so beautiful. Assumption is verified by this kind of OLS procedure. Yeah. So this is our assumption number 2. This kind of assumption, the key point is here. Epsilon 1, epsilon I, xi, when we write it in terms of mean deviations form, then it becomes something like covariance. Then the covariance equals 0. That is the assumption of this one. Okay? Anyway, if you don't understand it, this is the second normal equation of orders. The meaning, these two variables, they are not correlated, or their covariance equals 0. Okay? So this is the second assumption of OLS. Okay. Then we have something more. So I should not delete this part. Let me just delete this part. I will use that part later. In my third assumption number 3, I told it no multicollinearity. I will explain this part later. In simple terms, this no multicollinearity means that determinant is non-zero. But I will explain this one later. Okay? At this moment, forget about this part. Okay? Then, what we want is, in case of OLS matrix version, what you have is something like y equals xb plus e, this kind of thing. Okay? This one, E has some kind of distribution. Mean zero, variance, covariance matrix is sigma square, I kind of thing. Okay? So expected value of E equals 0. Variance of E is sigma square I. This is some kind of assumption. Then, what we need to do is, we can define this matrix in this way. y1, y2, y3. And 1, 1, 1, x1, x2, x3, alpha and beta, plus epsilon 1, epsilon 2, epsilon 3. This way. Okay? This is Y matrix, this is X matrix, this is B matrix, this is E matrix. Okay? Then, what we need to calculate is one matrix, this one, something called X transpose X. Okay? This one.
不是求导，那是转置。F transport.
Then, what is X trans? This is X matrix. 1, 1, 1, x1, x2, and x3. What is X transpose matrix? 1, 1, 1, x1, x2, and x3. This way. Okay? This is X transpose X matrix. You will see this matrix many times. So remember this one. Then when you calculate this kind of X transpose X matrix, let me write down here. What you have is something like this. What is the first term? 1 times 1 plus 1 times 1 plus 1 times 1. Okay? 1 times 1 plus 1 times 1 plus 1 times 1. Okay? What is this part? Here, 1 times x1 plus 1 times x2 plus 1 times x3. That is x1 plus x2 plus x3. Okay? Here, x1 times 1, x plus x2 times 1 plus x3 times 1. That becomes x1 plus x2 plus x3. Here, x1 times x1.
x1 squared.
Yeah. x2 times x2 plus x3 times x3. This way. Okay? Then this is the same as 3 plus x1 plus x2 plus x3. That is summation I equal 1 to 3 xi. Here summation of I equal 1 to 3 xi. Summation I equal 1 to 3 xi square. Okay? This is X transpose X matrix. The property of X transpose X matrix, what is 3? This is number of observations. 1, 2, 3. When you have 4 observations, you will have 4 here. What is this part? This is summation of xi. You sum up all the value of xi. Okay? This part is summation of xi square. Okay? That is the property of X transpose X matrix. Okay? So let me write down. Oh, maybe I can use this one here. Okay? Then let's calculate. I don't need that. Let's do it later. Let's calculate X transpose Y matrix this time. Okay? Then what is X transpose matrix? 1, 1, 1, x1, x2, x3. Okay? Then what is Y matrix? y1, y2, y3. This way. Okay? When I calculate this one, what is the first part? 1 times y1, that is y1 plus y2 plus this one. This one is x1 times y1 plus x2 plus y2 plus x3 plus y. This one. Okay? Then this is the same as summation of yi, summation of xi, yi, from I equal 1 to 3, I equal 1 to 3. This way. Okay? The first part is summation of yi. Second part is summation of xi times yi. Okay? Then, oops, I think I need to, maybe I can use this part here. What we are trying to calculate is x transpose, x transpose x, let me write it down together, okay? And b equals x transpose y, okay? We calculate this part, x transpose x here, okay? Then this one is 3 summation xi summation xi summation xi square. Let me skip this part, okay? It's from I to 1 to 3, but what's B matrix? Alpha and beta. Okay? What is X transpose Y matrix? Summation yi summation xi y, this way. Okay? So this is X transpose X matrix. This is X transpose Y matrix. X transpose X matrix here, B matrix, X transpose Y matrix. Okay? Then if I write down this one, when I calculate this one, is the same as 3 times alpha plus beta times summation xi equals summation yi. That is the first part. This one times this one plus this one times this one equals this one. Okay? The second one is alpha times summation xi plus beta times summation xi square equals summation xi yi. Okay? I can write it down in this way at the same time if you want. Or just these two equations. Okay? So this is the meaning of this equation. Okay? Then let's go back to here. What is this one? Let's forget about this part. Let's rewrite this part. Okay? Then this kind of summation part is you can distribute it. Okay? Then this one can be written as summation I equal 1 to n yi minus, if you sum alpha n times, this one becomes n times alpha. Okay? If you add up alpha 3 times, that becomes 3 alpha. Minus beta times summation xi equals 0. Okay? This is the OLS. Our objective function take derivative with respect to alpha. Then you will get this result. I can make this result. If I rewrite this one becomes this one. Okay? When I rewrite it again, summation I equal 1 to n yi equals n alpha plus beta xi of summation. This way. What is this one? You can see it here. Summation yi equals 3 alpha. In this case, we have 3 observations. When you have n observations, n alpha plus summation xi. Okay? Basically, this part means this equation. Normal equation number 1. Okay? Then this part is normal equation number 2. When I rewrite this part, okay, this summation is, we can distribute it. Okay? Then this one is the same as summation I equal 1 to n yi xi minus alpha times xi minus beta times xi squared. This way. Xi times yi here. Minus alpha times xi here. Minus beta times xi minus beta xi squared here equals 0. Okay? When you rewrite it, distribute this summation sign, summation I equal 1 to n yi xi minus alpha, summation I equal 1 to n xi minus beta, summation I equal 1 to n xi squared equals 0. This means that summation I equal 1 to n yi xi equals alpha, summation I equal 1 to n xi plus beta, summation I equal 1 to n xi squared. This is the same as this one. Summation xi yi, alpha summation xi, beta summation xi squared. Okay? This simple condition means these two normal equation of OLS. Okay? Basically, we have these two normal equations. Okay? The two normal equations, they can be written as this matrix form. Okay? This matrix form, it can be written as this way. Okay? What we want to calculate in OLS is the value of alpha and beta. Okay? It has two equations. Equation number 1, equation number 2. Two unknowns. Unknown number 1, alpha. Unknown number 2, beta. Okay? Two equations, two unknowns. We can solve the system of equations. Okay? In case of this kind of matrix form, how did we solve this kind of thing? We multiply inverse matrix here. This way. Okay? You have x transpose x here. This matrix is multiplied. What you want to calculate is B. Okay? Then what you have done is pre-multiply inverse of it. Okay? Now you can think this x transpose x as one matrix. Okay? X transpose x is, I calculated here, that is 2 by 2 matrix. 3, 7, 7, 16, something like that. Okay? So this is X transpose X matrix. X transpose X matrix. You can think about this one as number 3, 7, 6, 6, 17, something like that. Okay? Then this one and this one, we pre-multiply inverse of it. Something inverse times something, what is that? That is identity matrix. Okay? That times B equals X transpose X inverse X transpose Y. So in OLS, you will see this formula, identity times something, that is the same. This one. is X transpose X inverse X transpose Y. This is OLS estimator of matrix. Okay? This one. In the other way, let me delete this one. In this case, the B matrix is alpha and beta. We are solving the system of equations together. So in matrix, we are calculating alpha and beta together. Okay? But if you remember, in case of mass version, beta hat is summation I equal 1 to n xi minus x bar yi minus y bar summation I equal 1 to n xi minus x bar square. Okay? This was the formula of beta hat. Indeed, this one is very similar to this one. This inverse part is here. Okay? This is anyway x times y. X times y. Okay? So they are not identical, but if you see, and indeed when I do all the mathematical calculation, I can show that they are the same, but in terms of intuition, okay? Intuition, you run this one. Beta hat is xi minus x bar times yi minus y bar divided by xi minus x bar square. In terms of intuition, x times y here. Okay? And then x minus x bar square, x transpose x inverse. This one is something like dividing it. Okay? And then this kind of, what is it? Matrix form, it generally has summation inside. Okay? So, this is the way of using mathematics, but mathematicians, statisticians, economists, they are good at mathematics. Instead of using this long form, they simply write this one. Okay? So this is OLS matrix of OLS matrix version of estimator. Okay? This one, you will see this kind of formula over and over and over in OLS. Basically, it means that do this calculation and solve the system of equations. Then solution is this one. Okay? So it takes some practice. So go back to your home, review what I said, do it again and again and again. Okay? This time I recorded it on YouTube, so if you want, you can watch it again. I hope these things are visible, but anyway, practice and practice and practice. When you get accustomed to this kind of thing, OLS or data analysis becomes a way easier. Otherwise, when you see this one, you have no idea. Then you have no idea what's the next step. But anyway, if you understand the logic behind this one, you don't fear about this. If you have no idea, this one's too fearful. Oh, I am not good at mathematics. I have no idea what's going on there. Then why don't I simply give it up? That is the trivial kind or typical procedure of logic. But if you understand the logic behind this one, oh, I don't understand entire process, but I learned it. I know something about that, then I can proceed to the next step. That is the purpose of this class. Okay? So, practice, practice, practice. as I remember, I practiced this kind of thing probably at least 3 years. Yeah, because when I see some kind of new theory, then I cannot but come back to this kind of thing. Review all my things, and then later I can proceed to something new. And when I see something new again, then I go back to here and do all the mathematics, compare the mathematical version and the matrix version, and then get more understanding, and then learn something new. It took me at least 3 years to do that. And then it took me probably 1 more year to read entire econometrics textbook from the beginning to the end by myself. And after that, I feel very comfortable about this kind of things. So it requires some time, a lot of practice. I don't think you guys gonna do those kind of things, but anyway, practice is required. And when you do this kind of things without the help, then you will understand, you will see the logic behind OLS much better. Okay? So this is something behind OLS matrix. 1 hour, and I think that's just enough for today's class.
Thank you.
Okay? So basically, in case of mathematics, learning a lot, it generally do not help you. I'm stopping my class at this moment because I want you guys to understand this part completely. Okay? So go back to your home, try to do a lot of practice of this one. Then tomorrow I will teach the remaining part of it. Okay? Mathematics requires step-by-step practice. Okay? I know that you guys are tired, need to do a lot of things, but before tomorrow's morning class, please practice this one. Okay? You still have 2 more hours in my class. Okay? So, self-study. Okay? So, this one, when I do this kind of thing, it looks relatively simple and logical. When you guys do it by yourself, there are so many problems. So try to overcome those kind of problems by yourself. It will make your OLS knowledge bigger. Okay? Study this kind of thing again. Okay? I gave you the handout last semester, or you may have some kind of things, or you guys can talk each other and do. If you forget the chain rule and what is it? Partial derivative, study it again. Okay? Study and study and study. I told you, it took me 3 years to get completely understand this kind of things. Practice and practice and practice, then that will make you feel good about this kind of thing. Okay? So, please review this kind of things and good luck. Okay? So, let me end today's class at this moment.